Well, good morning and welcome to Science. Today, what we want to do is continue talking about things floating and sinking like yesterday. And what we want to do specifically is talk about an old, crusty scientist from long, long ago, Archimedes. Now, maybe you've heard the story, maybe not at school because it is slightly school inappropriate here, but we'll see what you think about it. Now, Archimedes was a scientist back in ancient Greece. And just like today, Archimedes knew about buoyancy and buoyant force, right? And he knew if you have an object and you find the mass of it, let's say this marble right here being 10 grams, he knew that if you take that marble, put it into a liquid, let's say like liquid right here, he knows that if you put it in the liquid and find the mass of it, it has less weight. Like, so let's say if it was if it was 10 grams, total here, you put it in the water, maybe it's only 5 grams. I mean, it's less. And this drove Archimedes crazy. He thought, it can't be true. How can you get something wet and it magically just, has less mass to it? That doesn't make any sense at all, right? But this is where buoyant force comes in that we were talking about yesterday. And Archimedes is a scientist that discovers what was going on with this. Now, he's so annoyed, right, as time goes on, studying this, force that's going on here and everything, that eventually he gives up. He goes home one day and he thinks, I've just got to take a break from this. I can't figure out what's going on. So just like today, ancient philosophers apparently really like their hot baths. Right now, I'm sure they didn't have electric hot tubs like today and everything, but they did have hot tubs, right? They had tubs they filled with hot water. Now, just like today, right, he wants his hot tub as full as possible. So that little, that little kind of drain overflow spout that's normally about here, right? He plugs it up with some Play-Doh or something like that, just like today, and he fills his hot tub up hot. He fills it up with high water, high water, high water, higher water. I mean, all the way to the very tippy top, right? He fills it to the extreme brim because he's like, I'm so frustrated. I just got to get, the deepest hot tub that I possibly can for the day. Now, here's where maybe you've heard the story, right? Archimedes jumps into the tub, and what happens? The water overflows, right? He jumps in, water starts pouring out all over. His wife is screaming at him, Archimedes, what were you thinking? Right? But it's at this point where our story takes a turn for the unexpected. It's good that you're at home because this is school inappropriate here, right? Archimedes is so amazed that because it finally just dawns on him what's going on here and everything, that as the story goes, right, he jumps up out of the hot tub wearing, well, let's just say nothing more than whatever you would wear in his own personal private hot tub, right? And goes running down the streets of ancient Greece screaming, Eureka, Eureka, I've discovered it. Now, it's thanks to this discovery that we call the Archimedes principle today. That's where a lot of the things we were talking about yesterday about floating and sinking and buoyant force, that's where this comes from, is from this guy's discovery. Because here's what Archimedes figures out, right? He thinks, okay, as he goes into the water, right, he displaces or moves some of the water out and everything, right? And the water flows out. And as the water's flowing out and into his bathroom and everything, and his wife is screaming at him and all that, he suddenly realizes, right, the amount of water that he displaces or moves, right, that water, if you could measure how much mass that water actually has, it's exactly equal to how much buoyant force is pushing him up, right? So just like if you're in a pool and you can jump up, but then you slowly come back down, right, because there's buoyant force, if you remember from yesterday, pushing up on you, well, that force is equal to how much water it displaces, right? So think about it. If you jump in a pool, the water inside the pool goes up ever so slightly, right? However much mass you are jumping in the pool and that buoyant force is counteracting, that force, that amount, volume-wise, is how much goes up for it and everything. So normally in school, I would show you this with some golf balls. I'll show you it with some marbles here at home, just because it's a little bit quicker and everything for you. Let's do a demonstration of the Archimedes principle. Now, normally in class, there's a whole lab that we do with this. I'd love to do a recording of that, but I just don't have all the equipment here in my home science laboratory for us. But what we can do is something that I would show you normally in class with Archimedes principle, and that is this guy right here, right? As you can see, I've got my graduated cylinder, and it has just a little bit over 50 milliliters of water in it. Now, according to the Archimedes story, when you have something that has mass and you put it inside of the container right here, right, the volume of, in this case, the giant marble right here, right, the volume of the marble has to be, displacing some of the volume of the water, right? So if I take the marble and I put it into the graduated cylinder, well, you can see, right? It's raised up a couple milliliters of water. And if I add more marbles, well, the water rises up, and the more marbles I add in there, the more the water keeps rising, right? So the marbles are what's called, they're displacing some of that water, right? And that is the key thing that Archimedes discovered way, way back when, that helps us out today. All right, and then let's get into the technical thing of what's going on here, right? So the Archimedes principle works like this, right? That buoyant force, that force that's pushing up on things, right? It's equal to the mass of the water that gets displaced. So that's where we get to this guy right here. This is called an overflow can. And the way that the overflow can works is, imagine you filled the overflow can up, filled it up with so much water that water's coming out the little spout right here, kind of like a teacup kind of thing and everything. And what you want to get this set up properly is just that, right? The water fills up, it comes out, and then eventually it kind of drips out and it comes to an end, right? So much, the overflow can here is filled up so much that theoretically at least, right? If you put one drop of water in here, one drop of water is going to come out there, right? Then what you need to get this to work is you take a container, you know, some kind of empty container, kind of like this guy right here. And what you do is you're going to take, to measure that buoyant force, take your object, say like a marble right here. You're going to put that marble in, right? And then that's going to displace a certain amount of water, right? Some water is going to come out. You're going to catch it in your container right here. And now here's where the Archimedes principle works, right? If you had, let's say, the weight, let's say our marble was 5 grams. If you could find the mass of it, you know, just kind of like hanging out over here just in your normal air, let's say 5 kilograms, right? If you dip it down into the water, and here's where I would do this for you in class normally, well, it's not just that it feels lighter, it literally is lighter, right? It's, in this case, 2 grams lighter, right? So you could pull it back out of the water, it would go back down to 5, or back up to 5 kilograms, put it back down into the water, it's gonna be less mass, right? It seems like mass just magically disappeared. But we know that's not what's going on. It's that buoyant force. It's the water molecules pushing on it harder on the bottom of the material than at the top of it, right? And that's that buoyant force that we have. What Archimedes discovers, though, is with your overflow can, or in his case, his hot tub, right? If the water that gets displaced, right, when you put the mass down into the water level goes up ever so slightly, right? But because in this case, there's this little thing, this little like pour spout right here, the water comes out into the little container right here, right? So you can see this water level and this water level, they're the same because this water level went up, but the extra went into the little container right here. And what Archimedes figures out is if you took just the mass of just this water, so not the container, because that would count as our tare, but just the water right here, guess what? It's exactly 2 kilograms in our example right here. So however much lighter the object feels, mass-wise, that's how much exactly the water that gets displaced with. And that is Archimedes' principle right there. And so that's what even today, that we use this principle even today, designing things like boats and submarines and stuff like that, like we talked about in yesterday's lab. So it all has to do with, you know, the density of the object, how much mass is it, how much mass is the water and everything. That's what's making things float and sink. Let me give you one last example right here. Here's kind of a silly example, but it's kind of got a cool, well, it kind of gets cooler as the video goes, right? So it's 2 kids doing their science project. Hold on here. They're doing their science project. It starts out relatively simple and benign, right? You've got them with some helium, having a little bit of fun here. So there you go, helium balloons. Oh, there you go, lighter than the air. But check out this gas right here. The balloon is floating on some sulfur hexafluoride. It literally floats on the gas, or in this case, they've got the fishbowl filled up with that sulfur hexafluoride, so much so an aluminum boat floats. Then if they scoop some of the gas up very carefully and pour it into the boat, look, the boat actually sinks down in, right? It gets heavier.
Hi, I'm Rosie, and I'm Anna, and we have some baby voices.
Yep, that part's cute. This part's terrifying. All right, so yeah, so those are all things about buoyant force and floating and sinking for you know, the last 2 lessons. So after watching this, you want to do the reading for today. After the reading, do the quiz, and then you're set for today. tomorrow we'll do rockets. All right, we'll do the rocket lab tomorrow, and the Mentos and soda lab. So that's something to look forward for you.